Dear students, today's lesson is about thermal insulation materials for building retrofitting. We will first make a brief description about the thermal energy you have studied before, the heat flow, thermal conductivity. We will discuss why we need thermal insulation and which materials are suitable for intended use. Let's first define the purpose of thermal insulation and why we need it for new constructions and retrofitting. The purpose of thermal insulation in buildings is to maintain a comfortable and hygienic indoor climate at low ambient temperatures. A minimal amount of thermal insulation is required to protect the construction elements against thermal impact and moisture-related damage. The main aim of thermal insulation in winter is energy conservation, leading to a decrease in heating demand and hence the protection of the environment. This aim has to be considered in new buildings as well as in renovating and retrofitting the building stock. And then we ask why thermal insulation is important for the civil engineers and the public. Half of the energy we use to heat or cool our homes can simply leak out without insulation. Insulation helps to save money on energy bills, reduce energy use and lower greenhouse gas emissions, reduce reliance on heating and cooling systems, and finally, improve comfort. Let's try to recall from the previous courses the terminology about heat transfer from materials. Thermal conductivity is a property of a material and is defined as the amount of heat energy transferred per unit thickness for a given temperature difference, expressed in watts per meter Kelvin. The lower this value, the more energy efficient is the material. However, the thermal conductivity of a material is affected by density, moisture, and temperature of the material. When the material is moisture saturated, the thermal conductivity is increased. The lower the coefficient lambda, the better is the insulating material. As long as we understand the meaning of lambda, now it is easier to learn about the U values. If you did not catch the definition of lambda from the previous slides, please watch carefully again while taking notes. Okay, now define the U value then. U value is the measure of the rate of heat loss through a material for 1 degree difference in temperature at either side of the material. As it can be understood from the definitions that thermal conductivity is a typical material property, while the U value can be calculated for structural members having different widths and/or for composite structural members made of different materials. The calculation of U values can be rather complex. The U indicates the flow of heat transferred from the inside out through an area of 1 square meter and a temperature difference of 1 Kelvin. Once again, the acronym is U and the unit is watt per square meter Kelvin. That's a necessity for proper heat insulation. It is to strive for the lowest U value as possible. The lower the U element in the structure, the less is its heat loss. This table represents the typical U values for some selected thermal insulation materials. Have a look at cavity wall insulation materials. For cavity wall insulation, the U value of 0.30 can be issued by either 100 mm thickness of long polystyrene or 35 mm thickness of polyurethane foam board. As you see, different thicknesses values are needed to achieve the same heat transfer capacity for materials having different lambda values. Please check the U values of these materials carefully in this slide. Another important point to mention here is the high heat flow capacity of the windows. You can see that the U value for single glazing is 5.6 watt per square meter Kelvin, while this value may be reduced up to 4 times by double glazing energy-saving argon types. Let's define the thermal resistance or R value for structural members. Within the building, there is a transmission of heat from the environment heated indoor air to the cold outside, for example, through the walls outside or through the roof. Insulation's ability to resist heat flow, prevent heat leaking in or out, is described as R value. Insulation products with the same R value will provide the same level of insulation if installed correctly. The level of insulation needed will depend on the type of the building and the climate zone. Here you can see that thermal resistance is equal to 1 over U value, which is the thickness of the element divided by its thermal conductivity value. Here, the thermal resistance have a unit of meter square Kelvin per watts, and the thickness of the element is measured in meters, and thermal conductivity is watt per meter Kelvin. This formula is valid for single structural members. For multiple layer calculations, we will discuss in another lesson. Now it's a question of matter when to insulate the buildings. The best time to install insulation is when you are building or renovating. Insulation should be combined with good design, including passive heating and cooling, so it can do its job properly, keeping you comfortable all year round. Many specifications have minimum energy efficiency standards for new residential buildings and building extensions. Insulating your new home is one way to meet these minimum requirements. Retrofitting insulation is also possible. If you are going to insulate your home at a later stage, the effectiveness and cost will depend on how easy it is to install. For example, it may be more difficult to install insulation in less accessible areas, such as existing walls. Now let's talk about, one by one, some typical insulation materials and their important characteristics. How to choose the best material for insulation depends on the knowledge about the types of the materials, the intended use, and the type of the construction, of course, on economic considerations. The expanded perlite is used as a light granular insulation to fill cavities such as insulation of cavity between the rafters or the insulation of ceilings, granular insulation under the concrete floor, and granular insulation of floors neck, filling of padding between the wood. The expanded perlite can also be used for the production of thermal insulation, mortars and plasters. Its lambda value is between 0.04 to 0.06. The material is open to diffusion. It does not rot, and it has also a good resistance to pests and chemicals. It can regulate the humidity. Certain attributes of perlite have good acoustic properties, and it's a good material for sound insulation. The expanded perlite is not flammable. The fields of application are the restoration of damp modes due to condensation. Calcium silicate boards are applied mainly in the facades subject to protection. Calcium silicate is very open to the diffusion. The high porosity leads to a large capacity of water storage and capillary transport. Active regulation of air and moisture is possible. It is resistant to rot. The panels made of calcium silicate are not combustible. When applied within the building, make sure that calcium silicate boards are surface treated and protected. Rock wool. Insulating materials based on mineral fibers are proposed for all fields of application, except for the walls in contact with the earth and for insulating the roof parts which are damp. Its lambda value is between 0.035 to 0.04 watts per meter Kelvin. It has a good resistance to aging and comprehensive form of stability if the insulating material is protected against moisture. Rock wool is vapor permeable. It is pest resistant and non-putrescible. Class of flammability is low. In case of fire from temperature of about 250 centigrade degrees, the binder evaporates, causing a bagging insulating material. Basaltic rock wool. Thermal insulation of pipes, equipment, tanks, boilers, furnaces, fireplaces, and components of gas turbines are possible with basaltic rock wool. It has also a specific use on soundproofing industry. Its lambda value is between 0.038 to 0.055 watts per meter kelvins. Class of flammability is low. The fibers of basaltic rock without a binder are combustible. Cellular glass. Cellular glass is particularly suitable for the insulation for outside walls in contact with the ground, under the foundation, on the terraces, or on flat roof, and in general in all parts of the building susceptible to moisture. It's also suitable for the internal insulation. Its lambda value is between 0.04 to 0.05 watts per meter Kelvin. It does not absorb any moisture. It's resistant to frost and weather conditions, and its compressive strength is high. The panels are relatively light and non-flammable, non-putrescible, and resistant to organic solvents and acids. Wood fiber panels. Wood fiber panels are supplied in thicknesses from 10 to 100 mm for internal or external use. It's open to diffusion and its installation is quite fast. Insulation panels for insulation above or between the rafters of the roof, wall posts and wooden beam ceilings and walls for suspended facades and partition walls. Comparing with other insulation materials, it results in a higher capacity of storing heat. Its soundproofing properties are appreciable. In the points at high risk of moisture, wood fiber panels having hydrophobic properties are preferred with the addition of natural resin rather than bitumen. It's flammable. Cork. The cork is obtained from the bark of the cork oak. Today, the insulating panels are made of cork or the impure expanded version, that is, without addition of other substances. The cork bark is minced, and the granules are then baked in special tanks with high vapor water pressure and temperature of about 370 centigrade degrees. Cork insulation panels are also suitable for soundproofing or for stamping noise. It has a high storage capacity of heat. Under the influence of moisture, it loses its insulating effect. It has a good shape stability and a good permanent elasticity. It is resistant to insects and fungi. Hemp. Suitable virtually for all common applications. Insulation panels are for the facade. Insulation panels and mats for thermal insulation in walls, pillars, ceilings with wooden beams, roofs and suspended ventilated facades. Infill material for filling cavities like hemp ropes for joints of windows and doors. Soundproofing panels under the floor covering. Bulk fragments of hemp as insulation fill for the padding. Its lambda value is 0.04 and hemp fiber absorbs moisture up to 1/3 of its net weight and dries with no leakage head. It also has a high capacity of storing heat compared to other insulating materials made of mineral fibers, like glass wool or rug. Resistant against rust, vermin, rodents, and mold. With an impregnation based on soda, aluminum phosphate, or salts of boron, it reaches a flammability class of polyurethane PUR. PUR insulating panels are used in construction mainly for continuous insulation above the rafters, airing and insulation of boilers and pipes. It has an excellent thermal insulation property with lambda value of 0.03. The polyurethane foam, which has tight gas diffusion, has lambda coefficient of 0.025. It's covered on both sides with an aluminum film thickness of 0.05 mm or a non-woven mineral. It's available in different classes flammability. In case of fire, formation of toxic gases such as isocyanates, prussic acids, and other compounds phosphorus. Expanded polystyrene, EPS. It is used for insulation panels for facades as coating, insulation panels for the insulation of basement and external insulation of foundations, soundproofing on the floor covering, and it's preferred as panels for roof insulation. If using interlocking panels in non-ventilated roof, it is important to ensure an effective vapor barrier to the panels. It can be used in reverse structure roof insulation through hydrophobic panels. Its lambda value is between 0.035 to 0.04. EPS is resistant to rotting. The service life of the panels should be more than 30 years in accordance with actual standards. Its flammability class is 1, so in case of fire there is a strong formation of dense smoke. Extruded polystyrene, XPS. The extruded polystyrene is used for applications in wet ambient. It's used for roof insulation, panels, green roofs with terraces and floors. It's also used for panels for the outer insulation against the ground. The extruded polystyrene panels in this application are glued to outer vertical waterproofing. To protect them and to facilitate the discharge of water on outside can be applied over a drain membrane. Its lambda value is between 0.035 to 0.04. The absorption of water is extremely small because of the expanded closed cell structure and the expansion of the film on both sides of the panel. Its compressive strength is high and it has flammability class 1. In case of fire, there is a marked formation of dense vacuum insulation panels made of evacuated microporous silica coated with a film of metallized plastic that keeps the vacuum. It is used for insulation of the ceiling of the basement or under the floor. They can be installed in such a way that it's not to be damaged. Its lambda value is 0.0042. A vacuum panel with a thickness of 2 cm produces the same action as an insulating panel polystyrene of 20 cm thick. The product should be processed with particular care to not to destroy the protective film and to avoid breaching the vacuum. Manufacturers provide a maximum thermal conductivity of 0.02 watts per meter Kelvin. They are produced in any size. The production of vacuum insulation panels allows dimensional tolerances minimum 1 mm in order to avoid leaks in the joints of. What's next? Now watch the videos about installation of thermal insulation materials and then take the quiz. Good luck!